Hi, Luke. Welcome.
Hi.
Tell us a few words about yourself and about the tool you want to show us.
Yeah, sure. So I'm Luke Marsden, the founder of a small consulting company called MLOps Consulting. Before that, I built an end-to-end MLOps platform that was called .science. And prior to that, I guess I've got a bunch of experience in the kind of DevOps software engineering space, working with cloud native, CI/CD, monitoring, continuous delivery, that kind of thing. Yeah, so excited to share something that I've been working on today.
And can you tell us a few words about the tool?
Yeah, sure. So I'll share my screen. Chassis it's basically a tool for turning models that are in mlflow into production-ready container images. And actually, do you mind if there's a part of the demo that takes a few minutes. So do you mind if I start the demo and then we jump into more of a description about the tool while we're waiting for something in the demo?
I do not mind at all.
Okay, perfect. Yeah, so I'll just show you really what Chassis does. So we've got a little test environment running here inside this tool called Test Faster that has like a Kubernetes cluster inside. So you can see a few things are running inside here. And there's also a Jupyter notebook. So what I'll do is I'll kick off a container image build, and then we can keep talking, because that's the part that takes a few minutes. So if we look inside here, and by the way, everyone can try this themselves on chassis.ml's homepage. There's this little launch test drive button here, so feel free to click that if you want to try this yourself. So I'll also just log into Docker Hub quickly, because that's where I'm going to push the image to. Okay, so Chassis has a Python library, so you can import that, and then we're just going to use that along with mlflow and scikit-learn to train a model, save it in mlflow format, and then use Chassis, the Python SDK, to connect to the service which is running in this Kubernetes cluster, the Chassis service, and build that mlflow model into a container image inside Kubernetes. So what I'm going to do is I'm going to define an mlflow pyfunc class. This is actually optional, but it allows you to do nice things like pre and post processing for that model. And then you can just define the conda environment as well. And then just run mlflow.pyfunc.save model. And then if we load the model from mlflow, we can check that we can actually run an inference on it. And we can see that this is the normal kind of mlflow format of model files, the ML model, the pickle file itself, and so on. So then I'm going to give the tool my Docker Hub credentials, which I will get like this. Oops. And then just define a little bit of metadata, in particular where I want to push to, and the files, the mlflow files that I want to build, and then I just call this chassis.ml.publish method. So what that's going to do is it's going to spin up a Kubernetes job inside the Kubernetes cluster, which is going to use a tool called Canico to do a container build that doesn't require the Docker socket. And then it's going to push the resulting container image that has the machine learning model baked into it. It's going to push that model to, or that container image to Docker Hub for me. And you can poll the status of that job like this. So that method just says, hey, this is active, it hasn't completed yet. And we can also go and look at what's going on from the CLI perspective just by tailing this Kubernetes job. We leave that running. then that will take a few minutes while that builds that image. And so during that time, we can keep talking.
Okay, I just want to make sure I understood everything you did. So you quickly trained an SVM model, right?
Yes.
So you locked this model with mlflow. So now you have this python mlflow thing, right? And you want to take the thing you just trained and then wrapped in mlflow and then lock, and now you want to deploy it. Right?
Exactly. And in particular, I want to deploy it to KF serving. I didn't mention that part, but the kind of one of the key points of what we decided to do with Chassis was to make it so that you can build container images that can be used in multiple places. So the image that we build here can be used in KF serving, which is popular kind of serving framework that's part of Kubeflow. It can also be used in the Modsy platform. I worked with the team at Modsy on developing this project, and we're also interested in adding support for other runtimes. And there's this kind of notion in this open model interface that is kind of part of this Chassis project, that there are some kind of principles around how we believe we should be baking models into images, and also how we believe that we should be making these images that get built by data scientists runnable in multiple platforms so that you don't get locked into one specific platform. So for example, we're interested in adding support for SageMaker here so that the models that you, the container images that you create here could run both in KF serving and Modsy and SageMaker, if that makes sense.
Plain Kubernetes or just for KF serving?
Plain Kubernetes would be an interesting one as well. I guess you could just have like, like a deployment.
Not everyone wants to have KF serving in their cluster.
Yeah, no, that's a really good idea. Just having like a plain Kubernetes target, that would be good.
Okay, so how long will it take now?
Probably another 5 minutes or so. So yeah, maybe we can go through a few of the other questions you've got.
Yeah, I do have a couple of questions. So how many people work on this tool?
So there's about 6 of us in total, myself, my colleague Phil, and Carlos. And then there's some folks on the Modsy team as well working on it, like Seth and Nathan and the team there.
Okay, interesting. And what are your plans with Chassis?
Yeah, so like I already mentioned, I'd really like to add support for more backends. So I think the tool gets more useful the more places that you can run it in. So like you can see in this architecture diagram, we've got support for mlflow as an input to the system right now. It's conceivable that we have other model management tools as inputs as well, and we can make that pluggable. So supporting sklearn or something like that. And then also plugging it into more outputs, more places that you actually run the models. So KF serving and Modsy are the first 2 here, of course. SageMaker would be another obvious one. And I'd love to hear from your listeners what they'd like to see in terms of where they'd like to be able to run their containers.
Okay, so how can they tell you that?
So the best way to get in touch with me is to just get in touch with me on Twitter. I'm Marsden on Twitter. So please get in touch and that would be great.
Okay. Is it still building?
Okay, so that's just finished.
Oh, okay. I have a couple of more questions, but let's. I want to see.
So I'll finish the demo and then we can do a couple more questions. So now that that's finished, we can try out KF serving. And so we're going to deploy the model that we just created to KF serving. If we come and take a look at the Docker Hub, we can see that this image was last pushed a minute ago. So I'm just going to copy that. And then we can deploy the model into KF serving. we're going to basically reference the image name in the KF serving spec. And then I'm going to run a few commands inside the SSH here.
What did you just run?
So I'm copying the YAML file, the KF serving file, out of the Jupyter container where we just wrote it. And then I'm going to kubectl apply it. I'll show you what's inside that file. That's basically the file that that has the container image name in it. And then, yeah, so if I go ahead and apply that, then we can also just export some environment variables that we need to make a request to that model now that it's up and running.
I'll probably need to ask you, how did you manage to run kubeflow on Minikube?
Okay.
I was trying to do that and
yeah. So this is so yeah, the predictor is booting up, and I think it normally takes about 60 seconds to start up. Yeah, the I guess that's kind of a side note. Like, how do we actually run all this stuff inside this Minikube cluster? It's this other project that we have called Combinator, and one of the things that we do is we make it easy to deploy these kind of test drive things. And so one of the components in here is kubeflow, which you can launch a test drive of that as well. And if you want to go and see kind of how that's actually deployed and how that works, then that's all on.
That's your project, right?
Yeah, this is a project that I'm working on as well. And then, yeah, we've got this Kubeflow mlflow stack. We've also got a Kubeflow on its own stack. And it's all Terraform all the way down, basically. So yeah, feel free to go and poke around with that as well. But yeah, so this is up and running now. It's been running for 105 seconds. So I'll just finish the demo. If we export service host name, that's just the host name that KF serving wants us to send a request on. And then we're going to copy this.
This is like a request that you want to send, right?
Yeah, exactly. And then this is the inputs that we want to send. And then we just go ahead and send them. And ta-da, the model is serving requests. So yeah, we went from data scientist just runs chassis.ml.publish with a little bit of metadata, including an mlflow model. And we went from that to running container image in production without the data scientist having to mess around with Docker or think about how to build production-ready container images. So yeah, that's chassis.
What the model is actually doing?
In terms of how it's actually,
I mean, what it is predicting.
Oh yeah, this model is, I think, this is
digits. Okay.
Yeah, this is MNIST. So very classic hello world.
Okay. You already have clients, right?
Sorry?
You already have clients, like this tool is used by customers.
Yes, we do. So so it's being used internally by Modzy. So that's kind of the biggest initial use case. And they are, I believe, integrating Chassis into their own kind of commercial end-to-end MLOps platform. The reason that we open sourced it is that we want to make it easy for other people, either who are building their own kind of internal corporate MLOps platform out of lots of different open source pieces, to solve this kind of container build pain point, and also for other kind of end-to-end platforms to integrate. There's some interesting stuff. I know we want to keep this kind of short, but there's some interesting challenges that we had to solve in order to build Chassis. And one of the biggest ones was how to build a container image inside a container. So this thing is actually running inside Kubernetes, and lots of data scientists are doing work inside Kubernetes, inside a Kubernetes pod, if they're using something like Kubeflow notebooks. And of course, you don't have Docker inside a Kubernetes pod. And if you say bind mounting the Docker socket to a security person, then their head explodes. And you're not meant to do that. So yeah, Chassis builds on top of this project from Google called Canico that I mentioned already, to do container image builds inside a container without using Docker. And yeah, that was one of the big challenges in figuring out how to do kind of multi-tenant container image builds in a secure way. So yeah.
Interesting. What's the most interesting insight you got from users, from the clients of your tool?
So I think the biggest one is that data scientists really shouldn't have to be building the container images themselves. Many data scientists, like, I don't want to underestimate data scientists. Many data scientists and machine learning engineers are capable of working with Docker, even if it's not like they're in it, not like where they came from. They maybe came from like a math background, not a DevOps background. But even if they can build Docker images, like, why should they be building Docker images? But then the alternative to that is that the DevOps teams have to build an image every time the data scientists want to deploy a new model. And that adds a lot of latency and friction, and in large organizations involves like opening tickets and waiting for people to respond to tickets. And so this is like, that was kind of one of the key insights here, was like, let's not ask data scientists to push models in containers. Let's also not ask DevOps people to build the models for them, but instead have this component that is a service that the DevOps team operates, that they can customize if they need to how it builds the images, and then just give the data scientists a Python SDK, because it makes it easy to use. So yeah, I think that was the main one. The other insight was really, yeah, like I already mentioned, this notion of kind of the pluggability, and this idea that that I've got a diagram here, that that the resulting container image should be like a key that fits into multiple locks, if that makes sense. Like it should fit into a KF serving shaped hole, and it should also fit into like a SageMaker shaped hole or a Modsy shaped hole. And that by being able to distribute these models that run in multiple places, you're avoiding getting locked in, and you're also making it easy to share those models between different organizations, or, for example, put them into the Modsy marketplace. So yeah, it's that pluggability, I think, has had a good kind of positive feedback from the people who are using it.
Okay, thanks. Do you have any advice for the listeners?
That's a fairly general question, I guess.
Yeah, it can be anything. Like,
yeah. So
like, start using Chassis right now to something that is completely unrelated to today's conversation.
Yeah, I mean, I guess I guess as a DevOps team serving an organization that has a machine learning component, it's really worth spending time thinking about how to better serve your data scientists and how to reduce friction and like break down barriers between teams. And obviously we're kind of opinionated about this being a good way to do that, but just more generally, like, think about how to empower the individual data scientists to ship things into production quickly, whatever that means for you. Yeah, you'll reduce the kind of time to value for data science projects by doing that. and that will make people more successful. So
yeah, thanks. Thanks for showing the demo. Thanks for telling us about the tool. Thanks a lot.
Of course. Awesome. All right. Thanks so much.